Hello. Today we are going to be adding and subtracting rational expressions. So far we've simplified, multiplied, divided. Now today our objective is by the end of class you should be able to add and subtract rational expressions with both common and uncommon denominators. So go ahead, take out your books, turn to section 2B. 1.2, and let's find a blank page in that section. The page after your warm-up, the 2B12 warm-up, is a good page, nice and blank for us to jot some quick notes down. So don't forget that with these videos you can pause at any time, rewind at any time if I'm going too quickly or if you need to rehear anything. So adding and subtracting rational expressions with common denominators. If we have a common denominator, adding and subtracting rational expressions is super easy. The denominator stays the same, and the numerators, you perform the indicated operation to. So in this example, I'm going to take 5x and I'm going to subtract the quantity 25x plus 10 from it. So that ends up giving us 5x minus 25x minus 10, because you need to distribute that negative to both the positive 25x and the positive 10, all over 40x. Combine like terms, we get negative 20x minus 10 over 40x. And then it's like a problem from where we first started. Now we're going to see if we can simplify. So let's factor this out. My numerator, I can factor out a negative 10, and I'm going to pull the negative out with it because we never want a negative leading coefficient. And left over, I have positive 2x minus 1. And in my denominator, I have 40x. And so now I have a common factor between negative 10 and positive 40. Those two numbers simplify. So I can simplify this to get negative 1 times the quantity 2x minus 1 all over 4x. Besides getting a common denominator, the biggest difference between what we're going to be doing today and what we've been doing the last couple of days is that we're actually adding and subtracting things. So before we can factor, we have to first simplify. So yesterday and the day before that and the day before that, the main thing was don't distribute anything because you want to leave things in multiplication form. Here, we don't have that option because we're not multiplying, we're adding, subtracting. So we have no choice but to distribute anything so that we can then simplify with the intention to factor. You'll see what I'm talking about in a future example. So let's take an example here. I have that common denominator already, so I'm going to add these two fractions together. When you add fractions, denominator stays the same. Perform that operation on your numerator. So up top, I have 6x squared plus 8x plus 12 plus 9x. I can combine my like terms in my numerator to give me 6x squared plus 17x plus 12 over 2x plus 3. And now it's just like a problem we've been doing. Let's see if this thing simplifies. So let's factor that. No common factor, so nothing I can factor out, which means I'm going to have to use guess and check. Whenever you have a denominator, guess that first. So my possibilities for 6x squared are 1 and 6, 2 and 3. I'm going to pick the 2 and the 3 to match that 2x. 12, I have 1 and 12, 2 and 6, 3 and 4. I'm going to pick positive 3, positive 4 to match that 3 to see if it possibly factors that way. Now let's double check. That gives me 9x, that gives me 8x, which adds to give me 17x, which is what I want. Awesome. Ooh, erased a little too much. So we factored the numerator to be the quantity 2x plus 3 times the quantity 3x plus 4. My denominator is that 2x plus 3. Now, since I have multiplication, and the bottom just the factor, I'm going to cancel my factors, and I'm left with 3x plus 4. All right, so those are two very basic examples. Yesterday in class, we learned how to identify unknown values. So really quickly, before we actually move on to our book examples, let's take a second and do that so we don't forget. No need to identify our domain. Let's just identify the restricted values. So again, we identify restricted values by taking our denominator and setting it equal to 0 and solving. So in this example 1, x cannot equal 0, because if x is 0, we get 0 in the denominator, and that's not good. In example 2, let's take that denominator, 2x plus 3, set it equal to 0. We get 2x equals negative 3, so x cannot equal negative 3 halves, my restricted value. And again, how do I get that? Because I have fractions, and in math you can never divide by 0. So we have to do what we have to do to find that value of x that makes our denominator 0 and say, hey, that's not cool. We can't have that. So now the main question is, how do we add rational expressions, subtract rational expressions when we have an uncommon denominator? So the steps to do that are right here. First thing we're going to do is we're going to identify any restrictions in our denominator, anything that x cannot be. Once we do that, factor the denominator. And actually, you might do these two steps in one. And you might actually factor the denominator before identifying any restrictions, because typically you have to do step 2 before you can do step 1. Once we factor out our denominator, we want to find the least common denominator, meaning what can I multiply by to cancel every single denominator, or to make sure that every single denominator is represented. And then once you do that, you're going to multiply the numerator and denominator by that and simplify. It's a lot of steps, but you'll see what I'm talking about. So first things first, let's take a look at our example here. 3 over 5 plus 2 over x. 5 is just a number. It can't be anything other than 5, but x is a variable. It can be anything. So the only restricted value I have is 0. X cannot equal 0. No solving necessary there. So now we're going to find the common denominator. I don't have anything here that factors. So my common denominator, I need a 5 because the fraction on the left has a 5, and I need an x because the fraction on the right has an x. So my LCD is going to be 5x. So now I'm going to multiply the numerator and denominator by the least common denominator. And actually, I'm going to multiply the numerator and denominator by what's missing. So 3 over 5 plus 2 over x. I'm purposely going to write these far apart because I want to give myself room. So my LCD is 5x. 3/5 already has the 5. What it doesn't have is x. So I'm going to multiply the numerator and denominator both by x, because then I'm really multiplying by 1. And multiplying by 1 does not change the value, it just changes the way it looks. 2 over x already has the x, what it does not have is the 5. So again, if you multiply the top and bottom by 5, we get our common denominator, and then we're not really changing the value. So now this is my common denominator of 5x. In my numerator now I have 3x plus 10. Nothing factors, so that's my final answer. These get easier with practice, and tomorrow we'll be practicing some more. All right, let's go ahead and turn the page. Let's take a look at example 2. You may need to do some work on scratch paper. I don't know how much room the book gives you, but I know it does not always give you enough. So first things first, if you do not see a fraction, make a fraction. It makes it a lot easier. So that 3, I'm going to write over 1 so I can easily see, hey, my denominator of that fraction's x plus 1. My denominator of that fraction's just 1. So first things first, x plus 1 is the only thing that has a variable. So I'm going to set that equal to 0 to get my restrictions on x. X cannot equal -1, because when it does, -1 plus 1 is 0, and that's no good. So now I'm going to find my LCD. I need an x plus 1 because my first denominator is x plus 1. I also need that 1, but 1 times anything is just itself, so no need to write it. So now I'm going to rewrite my expression. Again, separated with large fraction bars so that I can easily multiply in an organized manner. 5 over x plus 1 already has x plus 1 in the denominator. 3 over 1 does not, so I need to multiply this by x plus 1 in both the numerator and denominator, so I get that common denominator but don't actually change my value. So that gives me my common denominator of x plus 1. My numerator is 5 plus 3 times the quantity x plus 1. So we get 5 plus 3x plus 3 over x plus 1. Simplify my numerator, I get 3x plus 8 over x plus 1. And nothing factors here, so we're done. All right, example 4. Here finally we're seeing two different binomials. So first things first, let's find our restricted values. Take those denominators, set them equal to 0. To find that x cannot equal -1/2 and x cannot equal 3. Now to find my LCD, my least common denominator, since 2x plus 1 and x minus 3 are two different factors, I'm going to need both of them. So I rewrite my fraction with a big fraction bar so I have plenty of room to multiply. Now 3 over 2x plus 1 has the 2x plus 1, but what it does not have is the x minus 3. So I'm going to multiply that fraction by x minus 3 over x minus 3. So now I have my common denominator. 8 over x minus 3 has the x minus 3, but it does not have the 2x plus 1. So I'm going to multiply my numerator and denominator by 2x plus 1. So now I'm going to simplify. My common denominator is 2x plus 1 times x minus 3. My numerator now is 3 times the quantity x minus 3 plus 8 times the quantity 2x plus 1. Now I'm going to simplify my numerator. I get 3x minus 9 when I distribute that 3, plus 16x plus 8 when I distribute the 8. Again, all over that common denominator. And let's combine like terms. So up top now I have 19x minus 1, and I get 2x plus 1 times the quantity x minus 3 in the bottom. My numerator does not factor, so that's as far as this problem goes. One thing that you'll notice as we're going through these, the numerators we're adding, the numerators we're distributing, the numerators we're then factoring, the denominators constantly stay as the product of, in this case, binomials, but whatever your common denominator is. Leave it as product of factors. Don't actually distribute it out. It'll make it a lot harder if I were to have distributed the 2x plus 1 into the x minus 3, because then later we can't cancel. So denominators you leave. The common denominator stays the same, doesn't change. It's the numerators when we're adding and subtracting that we're going to have all the work for. All right, so I have 2 extra examples that I would like you to try on your own. So at this point, please copy these 2 examples down on a blank page in section 2B12. In about 3 seconds, I'm going to show the answers. So at this point right now, go ahead and pause so you can try these 2 problems on your own. So ready, set, pause. All right, here are our answers. So example 5, our restricted values, x cannot be 0, x cannot be -1, because when you set 4x equal to 0, we get x equals 0, x plus 1 equals to 0, it gives us -1. So our LCD is going to be 4x and x plus 1. So fraction on the left has the 4x, does not have the x plus 1. So we multiply top and bottom by x plus 1. Fraction on the right has the x plus 1 but does not have the 4x. So we multiply top and bottom by 4x. So again, now we have that common denominator of 4x times x plus 1. So we can actually perform the subtraction with our numerators. So we have 3 times the quantity x plus 1 minus 4x. So that gives me 3x plus 3 minus 4x when I distribute the 3. Combine the like terms, we get -x plus 3 in my numerator, and then that common denominator of 4x times the quantity x plus 1. Nothing in my numerator factors. I could factor out the negative, but it does not really help us because nothing ends up simplifying further. But this answer would also be appropriate. Example 6. So this one, we actually have to do that second step of factoring the denominator. So when we take that denominator, 4k plus 12, factor out my GCF, I'm left with 4 times the quantity k plus 3. And we see now both denominators have that factor k plus 3. The denominator on the left just is 4 times that quantity. So my LCD is going to be 4 times the quantity, k plus 3. So my fraction on the left, 6k over 4 times, oh my goodness, 6k over 4 times the quantity, k plus 3, already has the common denominator. My fraction on the right has the k plus 3, but does not have the 4. So multiply top and bottom by 4. Now both sets of fractions have that common denominator, so we can actually subtract. So up top I get 6k minus 20 over that common denominator. 6k negative 20 have a GCF of 2. Factor out the GCF of 2. There's an intermittent step here, which you can't really tell because I canceled it. So up top we get 2 times the quantity 3k minus 10 over 4 times the quantity k plus 3. So that 2 and the 4 simplify, and we end up getting 3k minus 10 over 2 times the quantity k plus 3. Oh, and I showed it at top, but forgot to mention it. Restricted values. So when we take our denominator, set them equal to 0, since they both have factors of k plus 3, and that's the only part that has a k in it, we get the same restricted values. When k is negative 3, we get 0 in our denominator, so k cannot be negative 3. All right, so you have the rest of the period to work on your homework. And I will be here tomorrow, bright and early, if there's anything that you guys want to go over. Tomorrow will be day 2 of this lesson. So see you all tomorrow.